Hello! In this video, we are going to prove the following theorem. Let A and B be sets. If B is a subset of A and A is finite, then A set minus B is also finite, and the number of elements in A set minus B is equal to the number of elements in A minus the number of elements in B. Okay, now before we get into the proof, let's get some context. To start, we're going to say that the natural numbers includes 0. And for each natural number n, we define the following set. We define the set IN to be the set of all positive integers less than or equal to n, where the positive integers are just the natural numbers not including 0. Now, what do we mean by finite? Well, we mean the following. Given the set A, we say that A is finite if there exists a natural number n such that there is a bijection from IN to A. And it turns out that the natural number that satisfies this condition is the only natural number that satisfies this condition. So it's unique. Right? And we call this natural number the number of elements in A. And we denote it as follows. Just like that. And now, we're going to use two facts regarding finite sets in order to prove this theorem. The first one goes like this. Given any two sets, C and D, if C and D are finite and disjoint, then the union of C and D is finite. And the number of elements in the union of C and D is equal to the number of elements in C plus the number of elements in D. Another fact we're going to use to prove this theorem is, given any two sets C and D, if D is finite and C is a subset of D, then the following are true. One is that C is finite and the number of elements in C is less than or equal to the number of elements in D. And if C is not equal to D, then the number of elements in C is strictly less than the number of elements in D. To reference these two facts in our proof, I'll call the first fact theorem 1 and the second fact theorem 2. Okay, so now let's get into the proof. To start out, let's give ourselves two sets A and B, where B is a subset of A and A is finite. So we see that A is finite and B is a subset of A. But also, we know that A set minus B is a subset of A. So if we apply theorem 2, since A is finite and B is a subset of A, it follows that B is finite. And since A is finite and A set minus B is a subset of A, we have that A set minus B is finite. And next, we can apply theorem 1, since B and A set minus B are disjoint. Well, since these two sets are finite and disjoint, we have by theorem 1 that the union of those two sets is also finite. And the number of elements in the union is given by the number of elements in this set plus the number of elements in this set. However, since B is a subset of A, it follows that A set minus B union B is equal to A. And I'll leave the details up to you to figure out that this implies this. Well, since this set is equal to A, we can replace that set here with A. So if we subtract number of elements of B to the other side, we get this. So what we've shown here is that A set minus B is finite, and the number of elements in A set minus B is equal to the number of elements in A minus the number of elements in B. And that is exactly what we wanted to prove. So this completes the proof. And so yeah, that's pretty much it for this video.